Hello and welcome back. In section 2.2, we work on solving linear equations explicitly. So the idea of explicitly solving an equation is to write something like what you saw in your geometry classes, like a two-column proof. So we're not just showing what we did, but explaining to the reader why we're allowed to do that. Some common questions, a question I get almost every semester with this: what if we ignore all the new stuff you're teaching us and just do the equation? The equations are generally linear equations. That's covered starting in pre-algebra. That's considered trivial. You already know how to do that. What I'm saying is, can you learn this new stuff to explain why things work the way they work? So we'll start with just a couple more properties we know. Most of the rest of them we've already seen. One is the addition property of equality. Addition property of equality states that if A is equal to B, then A plus C equals B plus C. So in other words, we're always allowed to add something to both sides of an equation and still get a true statement. Since addition can also cover the idea of adding an opposite, which encompasses subtraction, we may also see this as A minus C equals B minus C. But this, the name of the property doesn't change. It's still the addition property of equality, since subtracting C and adding the opposite of C are the same. And a similar reason would exist for the right-hand side. The other property we need before we get started, the multiplication property of equality. If A is equal to B and C is non-zero, then AC is equal to BC. So we're allowed to multiply by the same non-zero number on both sides of an equation. And since C is non-zero, this does also cover the case of A over C equals B over C. So we're allowed to divide by the same non-zero number on both sides of an equation as well. Like I said, the rest of the ideas we've covered in previous sections. So let me go ahead and just start a fresh page here, and we'll get into some examples here. So we're going to solve. And we're solving explicitly here. X minus 8 is worth 10. So we have a statement column and a reason column. What are we doing? Why are we allowed to do that? So the x minus 8 equals 10 was just our given statement. That's what we started with. Our goal is, if we're going to solve this, the idea is to get the x by itself. The thing that's crowding the x is the subtraction of 8. We'll undo subtraction with addition. So x minus 8 plus 8 is equal to 10 plus 8. Yes, you want it on the same line. No, you don't want it beneath there when you're doing the 2-column proofs. So what allowed me to do that? What allowed me to make that change from here to the original? Well, notice I was adding the same thing to both sides. If it's happening to both sides, it's going to be one of our properties of equality. So this was the addition property of equality. So then we can either change the left side or the right side. I'll just change the, we'll do the right side first. So I'll hang on to this x minus 8 plus 8, and the right hand side I'll turn into 18. That was just arithmetic. So on the left side, I do see something that looks like one of the properties that we've gone over in previous sections. A number plus its opposite equaling 0. That is the additive inverse property. So x plus 0 is worth 18 by the additive inverse property. Now, even though we don't know what x is worth, we do know that no matter the value of x, x plus 0 will always spit out an x, because 0 is the identity element for addition, so that is my additive identity. Now I've got the x by itself, just a number by itself on the other side. Then I want to check domain. Remember in chapter 2, if the domain is not stated, we assume that it's the set of integers. $18 is in the set of integers, so I get to keep that, so that will go in my solution set. So this is the intersection of the integers with the possible answers to the problem, and that is the only number that will keep then. So that is our solution set. So again, make sure you're working on both columns and don't skip steps. Those are basically the two common questions I have is either what if we skip all the steps, or what if we don't write out the properties. If you're missing stuff, you're going to end up missing points. So make sure you are trying these problems out the way that I'm showing you. It's a new way to do them, and it will give you a much deeper understanding of how these problems work. All right, so we're going to run through another one. This one will be asked to solve, again explicitly, 2x minus x minus 5 is worth negative 11. So I'll make my statement column and my reason column. So first I'll just copy down the problem they gave us, and that will be our given statement. So here I notice that even though we don't know what x is worth, it is a factor in two separate terms, so I can take that common factor out using the distributive property. After that, we'll take care of the arithmetic in the parentheses. Now, even though I don't know what x is worth, I do know that 1 times x can be rewritten as x. Similar to on the previous one, how I knew that x plus 0 would always spit out x. This time, this is the multiplicative identity that I'm using, though. Now I've basically turned it into the previous problem. So in fact, I'll invite you to pause the video and see if you can finish this one on your own, splitting it into all the properties that we did on the previous page. Okay, welcome back. So the next thing I'll do is add 5 to both sides of the equation on the same line, not below. If I did something to both sides of the equation, it's going to be one of the properties of equality. So this was addition, so addition property of equality. It's up to you if you worked on the left side or right side next. If you worked on the left side first, negative 5 plus 5 is 0. X plus 0 is negative 11 plus 5. And that is the additive inverse property. And even though we don't know what x is worth, x plus 0 is always x by the additive identity property. And we can finish it off then with arithmetic. Again, since no domain was stated, we're assuming an integer domain. Negative 6 is in the set of integers, so we keep that in our solution set. Okay, so next up, we'll look at solving 4 times x is worth 24. Again, I'll arrange my statement and reason column. What are we doing? Why are we allowed to do that? So we'll start with the 4x is 24 as our given statement. I'm looking to get the x by itself. The multiplication by 4 is in the way, so I'll multiply both sides by 1/4. So 1/4 of 4x is 1/4 of 24. This happened to both sides of the equation. Anytime it happens to both sides, it's going to be one of our properties of equality. So this is the multiplication property of equality. Let's see, just to do a little less writing, on the right-hand side, I'll take care of the arithmetic. So 1/4 of 4x is worth 6 by arithmetic. So next, I'd like to regroup this on the left-hand side. I don't know the value of x, but I do know that if I group the 1/4 and the 4 together instead of the 4 and the x together, I can get a number out of that. So that's exactly what I'll do. And see if you can remember the name of the property that let us slide those parentheses back and forth. Hopefully you recall that is the associative property, this time of multiplication. So a number times its reciprocal is always 1. So 1 times x is worth 6. That is the multiplicative inverse. And no matter what x is, 1 times x is always x. That is the multiplicative identity. Six is in our set of integers, so this will go in our solution set. We'll talk in section 2.3 about what happens if we get a solution that is not in our domain. Okay, one more similar one. X6 is worth -2. We'll make our statement and reason columns. So this was just given. This time, what's keeping the x from having its own side of the equal sign is the division by 6. So we'll undo division with multiplication. So I will multiply both sides by 6. If it's happening to both sides, it's one of the properties of equality, and this was multiplying both sides, so this is multiplication property of equality. I'll take care of the little bit of arithmetic that we have there on the right-hand side next. Right now, x and 6 are grouped together. I'd like the 6 and the 1/6 grouped together. That's the associative property again. And which of the two associative properties are we working with? Hopefully you figured out multiplication. A number times its reciprocal always gives us a 1. 1 times x is -12. That is the multiplicative inverse. And 1 times x always gives us an x. That is the multiplicative identity. -12 is in the set of integers, so we get to keep it in our solution set. So really, the properties of equality are the only new ones. All the other ones we've gone over in previous sections. So we have you all try one out, start to finish. Again, we're solving explicitly, so try it assuming you're going for all the points that are going to be offered for the problem. So 9 times x is -54. Just go ahead and pause it, see if you can get all the properties on there. Okay, welcome back. So I've taken the liberty of starting us with our given statement. 9x is -54. It's the multiplication by 9 that we're trying to cancel, so we'll multiply by 9's reciprocal. So 1/9 of x, 1/9 of 9x is 1/9 of -54. That happened to both sides, so it's one of the two properties of equality, multiplication property of equality in this case. Then it's up to you which order you did the next thing. Some of you took care of the left side next, some of you took care of the right side next. So the order of the steps might be a little different, but you should have all of the steps. I'm just going to take care of the right-hand side first. So I'll keep the 1/9 of 9x, and the left-hand side positive by a negative is a negative, and 1/9 of 54 is 6. So a ninth of 9x is negative 6 by arithmetic. Then we need the associative property of multiplication to reorder the left side. A number times its reciprocal will always give you 1 by the multiplicative inverse property. And 1 times any number is that number by the multiplicative identity property. Negative 6 is in the integers, so that will go in our solution set. So our next problem just says, okay, well, what if we start working with sort of both addition property of equality and multiplication property of equality in one problem? All the rest of these have been one or the other. As you remember from your algebra days, though, a lot of problems will have both. So the next one we'll solve 3x minus 2 is negative 20. As usual, a statement column and a reason column. What are we doing? Why are we allowed to do that? As you hopefully remember from your 93, 95 courses, it can be solved either by taking care of the 3 or the negative 2 first, but that it was much, much easier taking care of the negative 2 first, undoing the addition or subtraction first, and then finishing it off with multiplication division. So that's exactly how I'll start this. I'll add 2 to both sides of the equation. Anytime I'm doing something to 2 sides of the equation, it's going to be blank property of equality. This one happened to be addition property of equality. Negative 2 plus 2 is 0. A number plus its opposite is always 0. That is the additive inverse property. And even though I don't know what 3x is worth yet, I do know that 3x plus 0 can simplify down to 3x by the additive identity property. Now I'll take care of that arithmetic. Okay, so now I've turned it into some problems like the last one that you did. So we'll multiply both sides by a third. So a third of 3x is a third of negative 18. That happened to both sides, so it's another property of equality, this time multiplication property of equality. I'll take care of the arithmetic next. Next, we regroup the left-hand side. See if you can remember what property that one has. So this was the associative property of multiplication. The number times its reciprocal is always 1 by the multiplicative inverse property. So notice we're seeing kind of the same properties appearing in roughly the same order each time. So it does look a little overwhelming at first, but just with a little bit of practice, you'll see that each time I do anything with the addition property of equality, I see these next things happen. Each time with the multiplication property, I have the same pattern happening each time. So a number times its reciprocal is worth 1. That is the multiplicative inverse. And even if we don't know what x is, we do know that 1 times x is the same as x by the multiplicative identity property. -6 is in the set of integers, so we do get to keep it. Okay, so there's one more type of problem in this section that we haven't looked at, and that is if we have sort of multiple x's in the same problem. So the next one, in fact, I'll just start us with our statement of reason. We'll solve the 12x is worth 2 by the quantity x plus 25. And that will be our given. This is what we're going to be asked to solve. So left-hand side, there's no simplifying that I can do. The right-hand side, though, I can rewrite that. So I'll hang on to the 12x, and we'll rearrange to have this as 2 times x plus 2 times 25. So this was the distributive property. And we'll take care of arithmetic next. So now I've simplified the left side as much as I can and the right side as much as I can, but I notice that I have variables caught on both sides. So I'm going to go ahead and subtract 2x on both sides. If it happened to both sides, it's one of our properties of equality. Left-hand side, we can pull that common factor of x. That is also the distributive property. So then we'll take care of the arithmetic. 10 times x is worth 2x minus 2x plus 50. So now on the right-hand side, even though I don't know what 2x is worth, I do know that 2x minus 2x is worth 0 by the additive inverse property. So a number plus its opposite will always give us a 0, even if we don't know what that number is. So after the inverse usually comes the identity, and that's the case here as well, additive identity. That's not to say that it's impossible to cram a different step in between them, but typically if you see an inverse, eventually an identity is coming as well. Okay, so now we have ourselves most of the way there. Now we can deal with the multiplication property of equality. Get rid of the multiplication by 10, so we'll multiply by its reciprocal. So 10 to the 10x is worth a tenth of 50. That's something, again, that happened to both sides, so it's a property of equality. Multiplication in this case. Ten to the 10x is worth 5. That is just the arithmetic. We'll regroup. 10 times 10 times x is worth 5. That is the associative property of multiplication. A number times its reciprocal is 1, so 1 times x is worth 5 by the multiplicative inverse. And like I mentioned, once you see an inverse, an identity is likely coming soon, and that's the very next thing that we'll have. I can't squeeze it onto this page, so I'll just bring it to the next page. So 1 times x is now an x. Right side is worth 5. That is the multiplicative identity that got us there. And since that is in the set of integers, that will go in our solution set. We are allowed to keep the 5. All right, so try out the 2-2 exercises. I know this section can seem like a lot at first, but if you break it down, if you look at what happens each time after I use the addition property of equality and what happens each time after I use the multiplication property of equality, you'll see that there's just sort of two very recognizable patterns that each problem will sort of follow. So it's challenging, but it is definitely doable. Remember to reach out to office hours or math club or math lab if you need any assistance. We also have the Academic Assistance Center available. If you have any questions, please get in touch. Otherwise, I will see you next time. Stay safe out there.